Today for day 6 of chapter 11, we're going to continue to talk about hyperbolas, and at the top here of the notes we have a few review equations and vocabulary words, and then a couple new ones that we're going to identify, and then continue to look at writing equations and sketching graphs of hyperbola. So a couple of review things. We have the equations of hyperbola. So if we have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. The major thing I want you to understand about that one is that hyperbola is going to open left and right. And the reason I know that is because our x variable is written first. And then notice a squared in the denominator is always the one that is first rather than the largest one like an ellipse. And then if the equation is written y minus k quantity squared first, then that hyperbola will open up and down. And the center will be at h comma k. And then we will sketch our graph and count our graph from that center. And then in terms of the asymptotes, want to notice the equation there is y equals, and it's plus or minus m, because each hyperbola has two asymptotes, and the slope would be, the easiest way is to count it from the center to the corners of the box we draw when we sketch our hyperbola, and then the h and k in the equation of the asymptote will come from the center. It'll always be counted from the center. So the way I like to think about it is the center is the center of the two vertices of the hyperbola, the center of the two foci, and the center of the two asymptotes as well. The asymptotes should pass right through the center of the graph. And then the new vocabulary words are what we call the transverse axis and the conjugate axis. And I think the easiest way to identify those is to sketch them. So the transverse axis, I'm going to sketch a hyperbola here. I'm just going to put it in quadrant 2. It doesn't really matter. So we have our little box here. And then the transverse axis is the distance from one vertex to the other. So if I draw my asymptotes here, let's say we make this hyperbola open up and down. So here's a sketch of hyperbola. I don't have an equation, but let's say we had one that looked like that. The transverse axis would be the total distance from one vertex to the other. And in this case, it's going to be twice our a value, because remember, a is always the distance from the center to the vertex. So the transverse axis operates much like the major axis in an ellipse. It's twice our a value, and it goes from vertex to vertex. And the conjugate axis would be the distance across our box in the other direction. And the way I like to think about it is that would be 2b. So whatever our b value is in our equation, twice that value would be the total conjugate axis. And the reason why identifying those vocabulary words now is necessary is because today we're going to focus on writing equations from information, more so than just sketching graphs. So you may be given the transverse or conjugate axis length, and then from there we should be able to start identifying parts of our equation. So again, I just sketch here, the distance from the center to the vertex is a, so the conjugate axis is twice that, and distance from the center to the edge of the box in the other direction is b, so the conjugate axis is twice that b value. So if we look at example 1, we're asked to find the center, vertices, and the foci of the hyperbola. In this case, we're just given the equation. This is much like some of the ones we did in day 5. The only difference here is if you look at the denominators of our x and y variable, they're both non-perfect squares, which is fine, but it will impact kind of how we sketch our graph here. So the first thing I'd like to do is identify the center. So the center of this is going to be -4, -6. So I'm going to plot that there, -4, -6. And then it's usually the best, in my opinion, to identify your a and b value, because from there is where we're going to start to sketch our box, which kind of builds the location of all of our hyperbola information. So a squared is always the first one. So a squared is going to be 12, and b squared will be 13, which means a would be the square root of 12, and b would be the square root of 13. So neither of those are perfect squares, like I said, but knowing that 12 and 13, if I took the square root of them, both of them will fall somewhere between 3 and 4, because the square root of 9 is 3 and the square root of 16 is 4, so those will be somewhere between 3 and 4 units, which means if I'm going to sketch them, I would go A units left and right, and I say left and right because our x variable is written first in a hyperbola. So I'm going to graph, 3 point something units right and 3 point something units left. And then b value is root 13, so that's also 3 point something units above and below our center. So I'm going to draw my box here. And that's going to be a really good reference for our hyperbola. It's not part of the actual hyperbola, but it's very helpful when sketching hyperbolas. And then the next thing I like to do is just identify the coordinates of the vertices. And in this case, because our vertices are at the edges of the box in the x direction, whatever those coordinates are would be where the hyperbola would open, left and right. So the way you find those coordinates is you go from your center, -4, and you add square root of 12, takes you to the right end point where the box is. And if you subtract the square root of 12, it takes you to the left end point of where the box is. So in terms of writing the vertices, you could write them as a single point with a plus or minus between, and go -4 plus or minus root 12 takes me to those two edges. And you should make sure you're adding that root 12 to the x variable of your center, because this is going to open left and right. So there are my vertices. If I want to identify the foci, so I have center, I have vertices. If I want to identify the foci, I first need to identify my c value. So the equation we use there is c squared equals a squared plus b squared. I'm going to draw my asymptotes in here. We're going to use those as a reference, but this problem doesn't actually ask you for the asymptote, but it's going to be helpful when we sketch. So c squared is going to be a squared plus b squared. So c squared would be 12 plus 13. So what I get is c equals 5 when I solve for c. And what c is the distance from the center to the focus. And the foci will be in line with the vertices and the center. So then if I sketch them, go 5 units right, 5 units left, they're my foci. And the coordinates of them would be, -4 was my x variable, or x value of the center. And then I'd go right 5 and left 5. I could actually sketch my hyperbola here. It looks something like this, open left and right. And then I should just identify the focal points. So it'd be 1, -6, and -9, -6. And again, that 1 and -9 just came from me adding 5 and subtracting 5 from my center. Takes me to those focus points. So we're looking at number 2. We're given some slightly different information. So we're given the transverse axis endpoints and the slope of one asymptote, and we're asked to write an equation in standard form. So the way I like to think of the transverse axis is that's really where the vertices are. Since the transverse axis goes from vertex to vertex, I will plot those, and those will also be my vertices. And what that's going to tell me is that if those are the vertices, this hyperbola should open up and down, and then I should be able to find my center, because the center should be exactly in the middle of those two vertices. So my center is -2, 2. I'm going to need that to write my equation. I have my vertices, which means I should also be able to find my a value, because a is the distance from the center to the vertex. So a in this case is going to be 4. And then I'm going to need to find my b value. I'm going to need to sketch the rest of this graph, but what we're given is the slope of the asymptote is 4/3. So what I like to do there is if I go up 4 to the right 3, count out a slope of 4/3, that would be where my asymptote would go through, which means the slope from the center to the corner is, like I said, 4/3, which should also tell you what your b value is in a second here. So I can finish drawing my box here, and b is going to be the distance from the center to the edge of the box, not in the direction where the foci are, which means the b value should be 3. So I have a, I have b, I have my center. I could actually write my equation here, but I'm also going to consider which variable should come first, because that matters in a hyperbola. So if this graph has vertices at -2, -2, and -2, 6, that tells me this hyperbola is going to open up and down. So I should write my y variable first. So it's going to be y minus 2 quantity squared minus the quantity x plus 2 squared equals 1. And then in terms of what goes underneath each variable is a should go underneath the first variable, not the x variable necessarily, or y. It's whatever one comes first. So in this case, y came first. So I'd put a squared underneath y and b squared underneath x. So I have, that's my equation there. And if I wanted to finish sketching this graph, I should identify my foci. So c squared equals a squared plus b squared, which tells me c is going to be 5 in this case again. And again, I would plot that 5 units above and below my center, since this is going to open up and down. And then I can sketch my hyperbola, and should look something like that. So that is how we would write the equation given the transverse axis and the slope of an asymptote. We weren't explicitly given the center, A or B. We had to find them from the information that was given. For example 3, we're again asked to write the equation in standard form for hyperbola. This time we're given the foci and the conjugate axis length. So what I like to do is just plot the information that I was given for the foci. So I'm going to plot my two foci. And although it's not explicitly given, if those are the two foci, then my center should be exactly in the middle of those two, or in the center. So my center is actually going to be at -3, -5. So I have my center, and then we're given the conjugate axis length, which means we should be able to identify something about this hyperbola. And the way I like to think about it is, because my conjugate axis is 4, that tells me that that's the distance across the box, not in the direction the vertices are. So if the total distance across the box is 4, then that I should be able to identify my b value. And because I know my center and my foci, I could also identify my c value. So c is 5, and then, like I said, my b value should be, in this case, 2, since the total conjugate axis was 4. So I have c, I have b, but in order to write my equation, I need a as well. So the way I'm going to find a is by using the equation I usually use to find my c value. So I have this here, 25 equals a squared plus 4, which was my b value squared, and then solve for a. So 21 is going to equal a squared, which means a is going to be the square root of 21. So I have a and b and my center. Should be able to write my equation. So before I do that, I'm actually going to finish sketching this graph. So again, a is root 21, which is somewhere between 4 and 5. So if I go up from my center almost 4 point something, somewhere between 4 and 5, and down from center there, I should be able to draw my box here. So like I said, a is the square root of 21. So my equation should be y first, since this is going to open up and down. The reason I knew it was going to open up and down is because my foci were aligned vertically, which means my vertices are up and down of center. So it should open up and down. So y minus 5 quantity squared, y plus 5 quantity squared, which is minus -5, minus x plus 3 quantity squared, all over, or equal to 1. And I need to figure out what values should go underneath what variables. And a should always go underneath the first one, and because y came first, I would put a squared underneath y and b squared underneath x. And then I do want to finish sketching this graph, so I'm going to draw my asymptotes in. So connecting the center to the corners of the box. And then again, this is going to open up and down, so it should look something like this. For example 4, we're asked to write an equation for the hyperbola below based on the graph. So looking at the graph, we want to try and make sure we identify our center, our a, and our b value, so that we can sketch this, write this equation accurately. So a is always the distance from the center to the vertex, and b is always the distance from the center to the edge of the box in the other direction. And then the center in this case should be 0, 0. And then I want to find a and b as well. So like I said, center is going to be 0, 0. And then a, in this case, is going to be from the center to the vertex, which shown by the coordinates there is going to be root 5 to the right and root 5 to the left. So a is root 5. And b is going to be 3, distance from the center vertically to the edge of the box. So to write my equation, I would have to think about which direction this opens, and because this opens left and right, that should tell me which variable should be written first. So the variables should come first should be x. Because the center is 0, 0, I can just write x squared minus y squared equals 1, and then I just need to put my denominators in the appropriate place. So what should go in the denominator, please be careful, is always our a and b values squared. Not a and b, but a and b squared. One mistake we'll have a tendency to make once we've talked about conjugate and transverse axis is sometimes we'll double a and b and put them in the denominator, which again, we need to square those values to put them in the appropriate place. So a squared would give me 5. That should go under x, and b squared should give me 9, and that should go under y. So writing the equation from the graph, hopefully, if we know where to find a, b in the center, should be pretty straightforward. Just remember that the order matters for x and y. Depends on which direction it opens, because subtraction, the order matters. And then just make sure you're squaring a and b and putting them in the denominator. So that's day 6, just a little bit of additional hyperbola vocabulary and writing equations from graphs and various combinations of information.